Hello, welcome to Applications of Derivatives Lesson 4, Finding Relative Extrema. Extrema is just a fancy word for saying minima and maxima, which are just fancy ways of saying minimums and maximums. So we're going to be finding relative maximums and relative minimums. All right, let's get at it right now. Actually, do you realize that we've already kind of done this when we found out when a function's increasing or decreasing, concave or concave down? I've already kind of talked to you about this. Well, let's get into it a little bit. So let's get our feet dirty. All right, go ahead and pause this, read this. Okay, we've already kind of done this, finding critical numbers, critical values. All right. And then we're going to use the first derivative test, at least right now. We will use the second derivative test later on to find points of inflection. We're not quite ready for that. We're almost there. Give me a couple more days and we'll be able to talk about points of inflection and how to find those using the second derivative test. Right now, we're just going to use the first derivative test. And guess what? You've already used the first derivative test without knowing it. All right, so let's move on. Like I said, let's move on. All right, your f of x is 3x to the fifth minus 20x cubed. So let's go ahead and find out what y prime is. That would be 15x to the fourth minus 60x squared. You betcha. Set that derivative equal to 0. 15x to the fourth minus 60x squared. Let's go ahead and factor that. I think we can pull out a monomial 15x squared. And when we do that, we're left with x squared minus 4. Hey, how convenient, Manning. Look at that, a difference of two squares. So let's just continue to factor. 15x squared, x plus 2, x minus 2. So our critical numbers are 15x squared equals 0, x plus 2 equals 0, x minus 2 equals 0. So x equals 0, x equals negative 2, and x equals positive 2. So now we're going to set up the first derivative test. Wait a minute, you've already seen this. F prime of x. Make that number line. This is actually the first derivative test. Put those numbers on. Negative 2, 0, 2. That's where we know f prime of x equals 0. So we got to pick values between negative infinity and negative 2, between negative 2 and 0, between 0 and 2, and then between 2 and infinity. And we'll try to pick some smart numbers. All right, I think negative 10 is a good one because I can take that to the fourth power. That would be 10,000. 15 times 10,000. Wait a minute. A negative to the fourth power. That's going to be positive, and that's going to be a whole lot bigger. So that's 150,000 minus, all right, 10 squared is 100 times 60. It's only 6,000. I think that's going to be a positive. All right, let's pick negative 1. Negative 1 to the fourth power would be 1 times 15. That's going to be 15 minus 60, that's going to be negative there. Let's put a 1 in here. 15 minus 60 is going to be negative. And if we put a 10 in again, that'd be 150,000 minus 6,000. That once again is going to be positive. So now, from this data, we can figure out where there are relative mins and relative maxes. There is a relative maximum at x equals -2 because f prime goes from positive to negative. At 0, it does not have a sign change at all, so there's no relative min or max there. I bet there's a point inflection there. We'll talk about that later. And there is a relative minimum at x equals 2 because f prime, yep, I heard you. Let's move it up just a little bit because f prime goes from, not for, from negative to positive. There you go. That's how you find the relative maxes and relative mins. Let's try it with one more function, and we'll be done with what's going on. Of course, you know what it's going to be. It's going to be that dreaded rational function again. So, f prime of x equals derivative of the numerator 4x times x squared minus 2 minus the numerator times the derivative of the denominator all over x squared minus 2 quantity squared. Alright, so let's see here. That would be 4x cubed minus 8x minus 4x cubed minus 2x all over. So f prime of x equals negative 10x over x squared minus 2 quantity squared. Alright, so let's find those critical values. Set it equal to 0. Thanks for the noise in the background, little girl. And multiply both sides by this denominator. 0 equals negative 10x. X equals 0. But wait, there's more. Where is the denominator? Undefined. Wherever x squared minus 2 equals 0, x squared equals 2, x equals plus or minus the square root of 2. Those are also critical values because that's where f prime is undefined. So now we're ready to set up our first derivative test. F prime of x. We've got negative root 2. We've got 0. And we have 2. No, root 2. Pick something bigger than root 2. Let's try negative 2 because this is about 1.414. Negative 1.414, of course. Put that 2 in there. Negative 2. 10 times negative 2. Numerator, positive. Denominator, definitely positive. Alright, let's put in negative 1. Negative 10 times negative 1. Positive 10 over another positive. And then let's put in 1. And then we have negative 10 over 1. That's negative. And now let's put in 2. And that's negative 20 over 4, which is negative. So on this, f of x has a relative, it's going from positive to negative, that would be maximum at x equals 0 because f prime of x goes from positive to negative. And that's what we're going to do. That's all it is. Seems pretty straightforward. This will end Applications of Derivatives Lesson 4, Finding Relative Extrema.